Now, I would like to be able to tell you that we divide decimals just the way we divide fractions. Unfortunately, division is awkward. What do I mean by division is awkward? Remember that we said we could write division as just the reverse of multiplication. We can write division as multiplication by the reciprocal. If we tried to divide decimals that way, we wouldn't necessarily end up with a decimal. For example, if we were to divide, say, 2.5 by 0.08, we would write 2.5 as 2/5 over 10. We would write 0.08 as 8 over 100. Right, one digit after the decimal point, 1 0 in the denominator. 2 digits after the decimal point, 2 zeros in the denominator. Then we rewrite that as multiplication by the reciprocal, right? In the numerator, we'll have 25 times 100 is 2,500. In the denominator, we'll have 10 times 8 is 80. This is perfectly fine fraction, but it's not a decimal. Notice, 80 is not a power of 10. So we can't divide decimals like we do fractions if we want to get a decimal for our answer. Instead, we divide decimals like we do whole numbers. We try to undo multiplication. Okay. I think that before we tackle decimal division, we need to take just a minute to review whole number division. I told you that this was coming. Here it is. How do we do whole number division? The process of doing whole number division is a process of guessing one digit at a time and then seeing what's left over. So let's do a fairly basic whole number example. Let's try 1,295 divided by 37. Okay, but wait, you say. That's not basic. 'Cause my 4th grade teacher didn't make me memorize the multiplication tables for 37. That's okay. We're going to do a little prep work. Right, we're going to write out a quick multiplication table for 37 to help us work this problem. So here we're multiplying 37 by each of the one-digit numbers. So by each of the digits that we might possibly be guessing. And there are lots of ways we can fill in this table. We can use repeated addition. We can do multiplication on the calculator to fill in the table. That's totally fine. When we fill in the table, this is what we get. If you're wondering, what I did in the background was to use a calculator to repeatedly add 37. This is going to help me because as I work through this, I'm going to be able to say at a glance what my guesses should be. Okay, I'm going to write out a long division bracket. 37 goes outside. 1295 goes inside. So I'm going to uncover one digit at a time. 37 doesn't go into 1. It doesn't go into 12. It does go into 129. The last number on my list that's smaller than 129 is 111. So 37 goes into 129 3 times. Subtracting off 8, 1, and then the 5 I haven't concerned myself with are left over. Now I'm going to ask, how many times does 37 go into 185? and I see 185 right on my list. It goes in 5 times with nothing left over. 1295 divided by 37 is 35. This is whole number long division, right? We guess one digit at a time. All right, let's see how decimal long division is different, because it isn't very much. There are many approaches that we could take here, and frankly, in reality, chances are good that the approach we'll choose is to use our calculator. But the approach I want to take is to ignore the decimal points, except for one key point I'm going to mention, and just divide as if I had whole numbers. And then, after I'm done doing division, figure out where the decimal point goes in my answer. Let's see how this works. Just like before, I'm going to set up a long division bracket. And just like before, I'm going to just make a list of all the single-digit multiples of 8. If you happen to know the 8s in the multiplication table, then you don't need this list. If you don't, take a minute and write it down. Okay, so there they are, all the single-digit multiples of 8. I happen to know the multiplication tables, so I wrote those down from memory. If you don't, you can use a calculator to either repeatedly add or to work out the single-digit multiplications. Right. Why did I just do 8? Because I'm pretending the decimal point wasn't there for now. Alright, so pretending the decimal point isn't there, I'm thinking 8 goes into 25. And 24 is as close as I'm going to get. 8 goes into 25 3 times. 3 times 8 is 24. I've got 1 left. Now this is the place where this process is different from whole number division. The key point to note is that if we have a decimal point, we can add on zeros after the decimal point without changing any values. 2.50 is exactly the same as 2.5. What that means is that we can write in a 0 here, bring it down, and say now how many times does 8 go into 10? And it goes in once. 1 times 8 is 8. Subtract, and we have 2 left. We have to keep going until nothing is left over, because having a decimal part of our answer, or giving a fraction part of our answer, or giving a remainder are all different ways of dealing with what's left over, and we aren't allowed to mix them. So let's have another 0. 8 goes into 20 twice. 1 more 0. 8 goes into 40 5 times. Nothing left. Okay. So our answer is going to be 3125 with a decimal point somewhere. Where does the decimal point go? Well, remember, the question 2.5 divided by 0.08 equals what means what times 0.08 gives me 2.5. So here's what I'm going to do. I'm going to write out the multiplication. So I've got 3125 times 0.08, and I want to get 2.5000. So in this number, I have 4 digits after the decimal point. In this number, I have 2 digits after the decimal point. The question, what plus 2 equals 4? Well, 2 plus 2 equals 4. So here we want 2 digits after the decimal point. We want to get 31.25 for our answer. 2.5 divided by 0.08 equals 31.25. Now, I have no doubt that you've learned a different method of doing decimal multiplication than this one. But our main purpose in doing decimal multiplication by hand is to gain insight into the structure here, that is, into what's actually going on. So we want to think about the fact that division is the opposite of multiplication when we're figuring out where to put the decimal point in our answer. We can check this on the calculator in case you don't believe me. 2.5 divided by 0.08 is indeed 31.25.